The world's first sixth-generation fighter has been revealed, and its capabilities are truly shocking. We're talking about a leap in aerospace technology that makes even our most advanced fifth-generation jets look, well, a little dated. But what truly sets this marvel apart isn't just its blistering speed or its ghostly stealth. It's the revolutionary AI co-pilot, the cutting-edge directed energy weapons, and a design philosophy that makes it, quite frankly, the most lethal aircraft ever built. In this deep dive, we're going to explore how America's new F-47 isn't just an incremental upgrade. It's a discontinuity, poised to change the very nature of air warfare forever. Why the sky just got more dangerous for the last 20 years or so. American pilots have enjoyed a largely uncontested sky. It was an era where our technological superiority allowed us a freedom of movement that few other nations could challenge. But let's be honest, that era is definitively over. We're seeing a rapid shift in global power dynamics, especially in the air. China's J-20, for instance, now patrols the Pacific with upgraded engines and a rumored AI-enabled fire control loop that significantly enhances its combat effectiveness. And then there's Russia's S-500 air defense system, a formidable opponent that can track traditional stealth jets from an astonishing 400 miles out and engage hypersonic targets above 100-kilometer altitude, extending into near space. This isn't just about individual platforms. Both nations have been busy constructing dense, layered defenses, what we call ringed bubbles, made up of advanced missiles, sophisticated radars, and powerful electronic jamming capabilities. These aren't just theoretical threats. They can turn what used to be a routine peacetime patrol into a potential suicide run for any aircraft. Venturing too close. The Pentagon has a name for this new reality, the post-stealth problem. Think about it. Every legacy fighter in our inventory, from the venerable F-15 to the advanced F-35, was designed before these complex, multi-layered air defense systems truly existed. If a major conflict were to erupt tomorrow, U.S. air power would face an impossible dilemma. Either stay safely outside these heavily defended rings, rendering them ineffective, or try to penetrate them and accept what could be horrific, unacceptable losses. It's a lose-lose scenario, and it's precisely why the Air Force pushed the Next Generation Air Dominance Program, or NGAD, with such urgency. This isn't some slow-moving bureaucratic initiative. NGAD is a highly classified effort that insiders have already nicknamed the F-47. And let me tell you, this jet is no paper concept. We've had flight prototypes flying since 2020, and the first actual wings are currently under construction at the legendary Palmdale facility. The program itself just moved from a black, meaning entirely secret, to a gray budget this year, which means some funding details are becoming slightly more visible, signaling its transition towards broader recognition and deployment. The F-47 isn't just about making incremental improvements to existing technology. It's designed to fundamentally reset the chessboard, ensuring air superiority in an increasingly dangerous world. Meet the F-47, the first sixth-gen fighter. So, what exactly is a sixth-generation fighter anyway? Forget everything you thought you knew about fighter jets. While fifth-gen aircraft like the F-35 are incredible, a sixth-gen platform, specifically the F-47, is more like a flying data center that just happens to break the sound barrier. It's not merely faster or stealthier. It's built from the ground up for a completely new kind of warfare, one dominated by information, artificial intelligence, and networked systems. The F-47 features a revolutionary tailless flying wing design, which is a major departure from traditional aircraft. Imagine something roughly the size of a B-21 bomber, but far lighter and incredibly agile. What makes it truly special are the materials. It's built from advanced graphene-infused composites. These aren't just any composites. They're designed to actively absorb radar energy rather than simply deflecting it, making the jet incredibly difficult to detect. This is a massive leap beyond current stealth technology. And talk about flexibility. Its internal weapons bays are completely modular. This means you can swap out a hypersonic missile for, say, 3 drone wingmen in less than 10 minutes. This kind of adaptability on the flight line is unprecedented, allowing mission planners to tailor the aircraft's loadout to the exact needs of the operation almost instantly. But here's where it gets really interesting. The cockpit is optional. Literally. The same F-47 airframe can fly with a human pilot at the controls, Or it can fly itself autonomously from crew stations located safely stateside, thousands of miles away. Or, and this is perhaps the most revolutionary part, it can split the difference. A human pilot can manage the broader battle space, making strategic decisions, while an advanced AI handles the nitty-gritty of dogfighting and tactical execution. This human-machine teaming is a core tenet of sixth-generation capabilities. That AI, codenamed Raven, is a beast. It runs on a photonic chip, which processes information using light instead of electricity, making it incredibly fast. To keep it from overheating during intense computations, the chip is cooled by the jet's own cryogenic fuel. This setup allows Raven to process the equivalent of 3 hours of F-35 mission data every single second. Try to picture a fighter that not only sees the battlefield in a complete 360 degrees, integrating every piece of sensor data, but also predicts where the enemy will be 30 seconds from now, then fires a laser that travels at the speed of light to intercept them. That combination of unparalleled situational awareness, predictive analytics, and instantaneous engagement is precisely why senior Air Force officers are saying the F-47 isn't just evolutionary. It's a fundamental discontinuity in the history of aviation. It's going to redefine what's possible in the air. AI co-pilot, the second crewman who never blinks. Let's face it, being a fighter pilot is one of the most demanding jobs on the planet. Traditional pilots have to juggle an overwhelming amount of information. Sensors, radios, fuel levels, weapons management, and, oh yeah, an enemy actively trying to kill them, all at once. It's a constant high-stakes cognitive overload. But Raven, the F-47's AI co-pilot, is designed to offload that immense burden, acting like a true partner in the cockpit. Imagine this scenario. During a recent classified test over the Nevada desert, an F-47 prototype with a safety pilot on board just in case engaged 5 virtual Su-57s simultaneously. Raven was directing 3 loyal wingman drones. The AI wasn't just flying the jet. It was suggesting the best firing angles, ranking threats by their probability of kill, and even managed to hack into an opponent's data link to feed them false radar pictures. The human pilot's main job? Simply approving the shots. Raven handled literally everything else. This isn't just automation. It's intelligent autonomy, where the AI provides tactical recommendations and executes complex maneuvers with lightning speed, freeing the human pilot to focus on the broader mission strategy. This level of autonomy also means an incredible safety net. If, God forbid, the pilot blacks out under extreme G-forces during a high-energy maneuver, Raven keeps fighting. The mission doesn't end. If the cockpit suddenly loses pressure at 65,000 feet, Raven takes control and flies the jet home, ensuring the pilot's survival. The Air Force likes to quip that every F-47 is essentially a 2-seat fighter, but the backseater weighs only 2 pounds and draws a mere 25 watts of power. It's a stark reminder of the efficiency and capability of this digital co-pilot. What's more, this advanced AI significantly slashes training time, where an F-22 pilot needs around 40 sorties to become truly combat ready. Early F-47 testers have reached similar proficiency in as few as 10. Why? Because Raven coaches in real time, like an instructor sitting right on your shoulder who never gets tired, never gets angry, and can instantly analyze and relay optimal combat solutions. It's an unprecedented acceleration of skill acquisition, meaning more pilots can reach peak combat readiness faster and more efficiently. Stealth. So advanced. It doesn't need a tail when we talk about 5th-generation stealth, like that found in the F-22 or F-35. We're mostly talking about carefully sculpted shapes and radar-absorbent coatings designed to reduce an aircraft's radar cross-section to something roughly the size of a golf ball. It's impressive, but 6th-generation stealth, as embodied by the F-47, takes a completely different approach. It's about disappearing entirely, vanishing into the electromagnetic noise floor itself. The F-47's leading edge isn't just a piece of metal. It's a single seamless piece of carbon nanotube skin. This isn't just strong and lightweight. It's laced with miniature apertures that can actively emit deceptive signals. What does that mean? It means the jet can appear to an enemy radar as either a harmless flock of birds or even a civilian airliner, making it virtually impossible to distinguish from background clutter. This is active stealth taken to a whole new level. One of the most striking visual features, or lack thereof, is the absence of a vertical tail. Why is this important? Because vertical tails, no matter how stealthy, present right angles that can reflect radar energy back to an emitter. By eliminating them, the F-47 removes a significant radar signature component. So, how does it control yaw without a tail? Ingeniously, micro-actuators along the trailing edge of the wing twist the wing a fraction of a degree every few milliseconds. This subtle, continuous morphing provides precise yaw control, while simultaneously scattering radar waves into harmless directions, ensuring no energy is reflected back to the source. Infrared signature. The heat an aircraft gives off is another major detection vulnerability. The F-47 tackles this by routing engine heat into its fuel, using the fuel itself as a heat sink. Then it bleeds that warmed fuel through millions of porous panels on the upper wing surface, spreading the warmth so thinly and efficiently that an infrared sensor sees nothing hotter than the surrounding sky. It effectively becomes invisible to thermal imaging. The net result of all these innovations is staggering. The F-47's effective radar signature is smaller than even today's dedicated stealth drones. Despite the F-47 being 3 times their size, this isn't just speculation. During a red flag exercise last year, an F-35 was pitted against an F-47 test article. The F-35's radar, one of the best in the world, never achieved a track solid enough to even fire a missile. Meanwhile, the F-47 generated a synthetic high-fidelity image of the F-35 on the pilot's helmet visor from an incredible 120 miles away. That's not just air superiority. That's air dominance redefined. Directed energy weapons. Bullets made of light for decades. Missiles have been the primary offensive weapon for fighter jets, but they come with a fundamental limitation. You can only carry so many of them in your weapons bay. Lasers, on the other hand, are limited only by the amount of electricity you can generate. And the F-47, ladies and gentlemen, is packing some serious electrical punch. It carries a formidable 150 kilowatt solid-state laser, housed in a retractable pod, tucked away behind the nose wheel well. This isn't science fiction anymore. It's a combat reality. In close quarters, within visual range dogfights, this laser can burn a hole through an enemy canopy in a mere 3 seconds. It can blind an infrared seeker on an incoming missile at the speed of light, rendering it inert. Or it can detonate incoming ordnance at a safe distance, acting as an active defensive shield. But its utility extends far beyond just close combat. Beyond visual range, that very same laser transforms into an ultra-high bandwidth data link. It can dump hundreds of gigabytes of critical intelligence to a satellite in low Earth orbit, faster than any radio frequency system could ever hope to achieve. This capability is a game changer for networked warfare and real-time intelligence sharing, tying directly into the Air Force's broader network modernization efforts. And for those harder targets, the F-47 also packs a microwave weapon. This isn't a precision beam, but rather a directed pulse that fries electronics inside a 50-meter bubble. Imagine disabling an entire surface-to-air missile site, rendering its radars, launchers, and command systems useless, all without causing any collateral damage to the surrounding infrastructure. It's surgical, non-lethal, and incredibly effective. Because both the laser and the microwave weapon draw their power directly from the F-47's adaptive cycle engines. They technically have unlimited magazines. This means a pilot doesn't have to worry about running out of ammunition in a protracted engagement. Analysts have calculated that in a scenario like a Taiwan contingency, a 4-ship formation of F-47s, armed with these lasers and microwaves, could neutralize an entire squadron of J-16s while still conserving its 2 internal hypersonic missiles for hardened bunkers or high-value ground targets. This shift is as profound, if not more so, than when fighters transitioned from machine guns to missiles back in the 1950s. It's a fundamental redefinition of air-to-air and air-to-ground engagement. Drone wingmen, the swarm that multiplies. Lethality. The F-47 isn't designed to fight alone. It's the conductor of a lethal orchestra. Each F-47 is built to command at least 3 collaborative combat aircraft, CCAs, which are the Air Force's new loyal wingman drones. These aren't just glorified remote control planes. They're intelligent, autonomous platforms designed to operate in complex, contested environments. We've already seen the CCA prototypes, designated YFQ-44A and YFQ-42A, flying autonomously alongside an F-22. These drones are incredibly versatile. They can carry their own air-to-air missiles, deploy electronic warfare pods to jam enemy radars, or be equipped with advanced surveillance packages to extend the F-47's sensor reach. When linked to the F-47, the entire formation behaves like a single, cohesive organism. Raven, the F-47's AI, assigns each drone a specific role in real time. One might scout ahead, another jams enemy radar, while a third acts as a missile truck, carrying extra ordnance that the F-47 can then launch remotely. If a drone is shot down, the AI instantly redistributes tasks among the survivors, ensuring mission continuity and adaptability. This resilience is a critical advantage. The result is an incredible force multiplier. Imagine this. 4 F-47s can bring 12 drones to the fight, fielding a 16-jet strike package that, to enemy scopes, appears as only 4 low observable contacts. This creates a massive tactical advantage, overwhelming enemy defenses with sheer numbers and distributed capabilities, while minimizing risk to human pilots in the precious F-47s. And here's a crucial point. These drones are relatively affordable. Each CCA costs roughly 1/5 of an F-35. This means the Air Force can afford to lose them in heavily contested airspace without risking human lives or the astronomically expensive, stealthy motherships. In war games, this mix of high-end manned fighters and affordable, autonomous drones drives an enemy's cost-exchange ratio so dramatically lopsided that Beijing, for example, would have to fire 10 surface-to-air missiles for every drone destroyed. They would bankrupt their magazines long before American stocks even begin to run dry. It's a strategy of smart, affordable mass that fundamentally changes the economic calculus of air warfare. Engine that shapeshifts in flight powering. All this cutting-edge technology is something truly revolutionary. The world's first adaptive cycle engine ever flown in a fighter jet. This isn't your grandfather's jet engine. General Electric's XA-1002 engine is a marvel of engineering, capable of morphing its internal geometry in flight. It can switch between a high bypass configuration, perfect for fuel-saving loiter and extended range, and a low bypass mode for blistering supersonic dash and maximum thrust. This transformation happens in less than a second, using pressure-activated vanes that redirect airflow. What does this mean for performance? The F-47 boasts a combat radius 40% greater than an F-22, all while supercruising at Mach 1.8 without needing to kick in the thirsty afterburner. Supercruise, the ability to fly supersonically without afterburners, is a huge advantage, allowing for rapid transit to and from combat zones without burning through fuel reserves. The engine's ceramic matrix composites are another key innovation. These materials can withstand temperatures 200 degrees hotter than current alloys, unlocking thrust levels above 45,000 pounds per power plant. Since the F-47 has 2 of these monsters, it can push past Mach 2.2 when needed, yet still cruise efficiently for an incredible 1,200 nautical miles. That extra range isn't just a nice-to-have. It's absolutely crucial, especially in vast theaters like the Pacific. In a future conflict, tankers, which are typically large, slow, and unstealthy, will be high-priority targets. The F-47's extended self-sufficiency means it can operate deeper and longer without relying on vulnerable aerial refueling assets. In recent exercises, an F-47 launched from Andersen AFB flew a complex combat profile over 1,000 miles of open ocean and returned with fuel to spare. An F-22, by contrast, would have needed 2 aerial refuelings to accomplish the same mission. This engine literally expands the operational envelope and reduces critical vulnerabilities. Digital engineering, from drawing board to runway and record. Time, if you look at the history of fighter jet development, it often takes decades to go from concept to combat squadron. The F-35, for example, had a notoriously long and complex development cycle. But the F-47 is on an entirely different trajectory, on track to move from contract award to active combat squadrons in under 12 years. How is this possible? The secret is digital engineering. Think of it this way. Every single bolt, every wire, every line of code for the F-47 exists first as a perfect virtual twin in a digital environment. This isn't just about CAD drawings. It's a comprehensive, interconnected model. Engineers can run thousands of Monte Carlo simulations overnight, testing everything imaginable: flutter characteristics, radar cross-section, thermal loads, and even maintenance access. They can identify and fix potential issues long before any metal is ever cut. This approach fosters incredible efficiency and collaboration. When a supplier in Kansas updates a bracket design, that change instantly ripples through the cloud-based model, and every subcontractor from California to New York sees it in real time. This eliminates costly delays and errors that plagued previous programs. The results speak for themselves. The first F47 prototype required 60% fewer labor hours to build than the F-35's first jet, and test flights revealed a staggering 80% fewer. Deficiencies. The Air Force successfully used this same digital engineering method on the B-21 Raider bomber and was so impressed with the outcome that they've mandated it for all future programs. Of course, critics will always claim that this approach is risky, that it relies too heavily on simulations, but supporters counter, quite convincingly, that software iterations and virtual testing beat expensive, time-consuming hardware rework every single time. Whatever side you fall on, one thing is clear. The F-47 is moving fast enough to make even China's own 6th-gen efforts look sluggish by comparison, giving us a critical edge in the race for air superiority. Cost reality. Expensive but cheaper than losing a war. Let's be upfront about this. Cutting-edge capability, especially at this scale, comes with a jaw-dropping price tag. Early estimates peg the flyaway cost per F-47 at roughly $300 million. That's nearly triple the cost of an F-35. It's a significant investment, no doubt about it. However, the Air Force argues that the total life cycle cost will actually be lower in the long run. Why? Because the F-47 needs fewer tankers thanks to its adaptive engines and extended range. It requires fewer dedicated support aircraft, integrating many functions internally or through its drone wingmen, and its advanced digital design and AI-driven diagnostics mean it needs half the maintenance man-hours compared to previous generations. These efficiencies add up over the decades an aircraft is in service. But more importantly, the Pentagon measures value not just in dollars, but in deterrence. If Beijing genuinely believes the F-47 can penetrate their anti-access area denial, A2AD bubble at will, making any aggressive action too costly or futile, then the likelihood of a Taiwan invasion drops dramatically. In that crucial sense, the fighter pays for itself without ever firing a single shot. It's an investment in peace through overwhelming strength. Congress has already funded 12 jets in the classified budget, and the current plan is to acquire 200 airframes by 2035. While that's a fraction of the F-35 fleet, raw numbers can be misleading when each F-47 can command a swarm of drones. This isn't just about having more aircraft. It's about having a qualitatively superior force that multiplies its effectiveness through autonomous systems. Think quality over quantity, or even better, quality multiplied by autonomous quantity. It's a strategic shift that ensures our technological edge endures. How the F-47 will change war forever. Put all these incredible pieces together, and the battlefield of 2035 looks radically, almost unimaginably different from today. Imagine this scenario playing out. An adversary wakes up to find their radar screens flickering, their critical data links jammed, and their military satellites blinded by coordinated cyber strikes. Out of that confusion, a quartet of ghost-like shapes appears deep inside their heavily defended airspace, maybe 400 miles in. These aren't just individual fighters. They're orchestrating a symphony of destruction through their drone wingmen. These drones, acting with precision and autonomy, destroy runways, collapse electrical grids with directed energy, and crater missile launchers, all without a single missile being fired by the defenders. By the time enemy commanders even realize what's truly happening, the F-47s have vanished as quickly and silently as they appeared, leaving behind only a 150-kilowatt calling card melted into a radar dish. This isn't some Hollywood script dreamed up for a blockbuster. It's the working concept of operations being written today at Air Combat Command. The F-47's very existence forces rivals to spend billions, even trillions, trying to plug holes in their defensive bubbles, resources they cannot then spend on projecting power or developing offensive capabilities. It's a strategic burden we impose on them without even engaging. The character of war itself shifts profoundly. It moves from attrition warfare, where victory is measured by who can sustain the most losses, to cognitive overload, where victory goes to whoever can process information faster and make better decisions under immense pressure. It moves from linear fronts and predictable battle lines to an everywhere and nowhere conflict, where the enemy can strike from unexpected vectors with devastating speed. In short, the F-47 returns the initiative to American commanders, ensuring that if the next war starts in the air, it also ends there, quickly and decisively. The takeaway: the F-47 is so much more than just a sleek silhouette on a hangar floor. It's a breathtaking fusion of artificial intelligence, adaptive propulsion, directed energy, and stealth science so advanced that yesterday's best fighters look, frankly, like props from a museum. This aircraft promises to restore the critical margin of technological superiority that American pilots enjoyed for decades, even as China and Russia furiously race to close that gap. Whether a major war comes or not, the mere presence of this sixth-generation Sentinel fundamentally alters strategic calculations in every capital around the globe. Air dominance isn't just a military advantage. It underwrites every other form of military power. Without it, our navies cannot sail freely, our armies cannot maneuver effectively, and our allies cannot truly trust American security guarantees. The F-47 and the entire NGAD family of systems it represents ensures that this dominance endures, redefining the skies for a generation and securing our nation's future. If you want to stay ahead of the curve on the technologies shaping tomorrow's conflicts, make sure to hit that subscribe button and turn on notifications so you don't miss a thing. And please drop a comment below. Do you think AI pilots will ever fully replace humans in the cockpit? Or is the partnership we're seeing in the F-47 the real future? Let's keep this conversation going.